This is a lecture about combining like terms, and we've been doing it basically all along when we've been adding and multiplying values. So we're going to add 253. We're going to add it to 412. When we've been doing partial sums, we've been looking at 253 by looking at the hundreds, the tens, and the ones. If I'm going to add to that 412, again, I look at it hundreds, tens, and ones. So when we combine like terms, we are just essentially adding the like positions, and we say that we have 600. Adding my tens position, I have 60, and adding my ones, I have 5. So we'd find the sum of this to be 665. So we're looking at this in terms of combining like place values. Well, when we switch to algebra, we're doing the same thing. We're going to combine like terms or like places. But in order to understand our places with algebra, we're going to use a little device called an algebra tile, which we've introduced you to before. We basically have three shapes. We have a large square, which we're going to say is x squared. Notice it is a square, and so the area of that is x squared, or x times x. The height of this is x and 1, so the stick that I like to call it is just x, and the little square is representing a single value 1. Now remember, if I have them in red in color, they are negative, and the other colored side would be the positive. So when I add like terms, I can actually use these algebra tiles to come up with my answer. So using a picture of x squared plus x squared plus x squared, I would have 3 of the larger squares in a pile. So what would I have total? I would have 3 x squareds. Looking at the next example, it looks like I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 of those sticks. And to represent that mathematically, it would be 5 sticks or 5 x's. So we're just adding how many I would have in a pile. In the next example, I would have 4 red single tiles, and I would have 5 of the yellow larger tiles. And if you remember, our opposite or inverse property tells us that a negative and a positive cancel each other and make that 0. And so I'm going to cancel out all that I can, and what's remaining is positive 1. So what we're going to do here is we're going to look at it two different ways. We're going to look at it algebraically and with tiles. So in order to look at it algebraically, we have to use this commutative pile. Okay, this commutative idea is to rearrange the piles into common items. What it is it's just a move. We're going to move values around, and we can do that because I can show you that 3 plus 2, which is 5, is the same as 2 plus 3, which is also 5. Now that works with addition and multiplication only. So let's go ahead here and look at what we're going to do with, first of all, our tiles. Negative 3 says I would have 3 red. I would have 2 x's, which means I would have 2 sticks, and I would have 4 positive tiles. So using the commutative property, I'm going to take my 4 positive tiles, move them to be with my 3 negative tiles because they are of the same shape. I'm going to use my inverse property and cancel out and make zeros. And my answer to this problem is 2 x's, because I have my 2 sticks and my 1 positive tile. Now we don't always want to use algebra tiles, so using the commutative property, what I did algebraically was I took the problem and I rearranged the position of the 2x and the 4 using this commutative property, which says this is the same as negative 3 plus 4 plus 2x. Now that I have like items together, I can add that, and that's equal to a positive 1 plus 2x. Let's look at the next problem. Again, using tiles, 3x plus 2 means I have 3 x's and 2 positives. Then it looks like I have a negative x, which means I have a red stick, or x, and I have 4 positives. Using my commutative property, I'm going to move these together. So I'm going to move them this way. Let's move them this way. And then this positive 1 moves into this pile. And just like before, a positive and negative cancel each other. So it looks like my answer to this is 2x plus 6. Looking at the commutative property using algebra, I'm going to take the 3x and I'm going to switch these two in position. Notice my x still remains negative and my 2 is positive. Adding like terms, if I think of this, I have 3 x's, I take one away. I had 3, I took one away, so now I have 2 x's and 6 tiles. Looking at the third example, all that's changed here is my shape. 2x squared means I have 2 larger, and I'm adding to that 5 of the singles, and then I'm going to add 7 squares. There's 4, 5, 6, 7, and I'm going to take away 9. So I'm using my commutative property as I form this pile so that I can zero out. And the only things that are going to cancel here are these units. The 5 are going to cancel with 5. And so my end result, if I count, is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 squareds and 1, 2, 3, 4 negative single tiles. Using my commutative property, I could have switched the 7x squared with the 5, combined my squareds, combined my singles, and gotten the same result. Number 4 is just a slight bit different. When you see a subtraction sign out in front, it says subtract all of that group of tiles. So I might have 3 x's, and I'm going to take away these tiles. I'm going to take away 7 x's and 2 singles. So in order to take them away, that means that from this pile here, I'm going to take away. So these then turn into negative, and these also turn into subtraction of tiles. So now I'm going to go ahead and make my zeros. These 3 cancel out. I'm left with 4 negative sticks and 2 negative singles. So what's happened here is the 3x, I took away 7x, and I took away 2. That's represented in the pile below of tiles. Now in this problem, I have a little bit different situation. I don't have x's, I actually have a y. So we're just going to use this idea of adding common terms. Taking a look at the terms, the values here, 4x and 2x, they are alike. Notice it's subtraction. So I'm going to first take 4x, take away 2x. I have 2 x's remaining. Now I'm going to take a look and find some more common. Remember, they have to look exactly alike. If it's squared, both of them must be squared. Here I have 3y. I'm going to add to that a y. So I have 3y plus 1y, which is 4y, and this negative 4 remains. 2x is left, 4y, and a minus 4, or subtract 4. So when you're adding like terms, just like place values, you add the like shape or the very same term, like terms.